As Feynman continued his explorations, he often reflected on how even the tiniest events can have consequences far beyond what we notice. In his quantum experiments, a single particle's path could interact with countless possibilities, each one contributing subtly to the outcome. The patterns that emerged weren't chaotic, they were precise, elegant, and often surprising. Observing this taught Feynman a key lesson. Reality is far more interconnected than our everyday intuition allows. Consider another scenario he might imagine. Suppose two electrons are entangled, linked in a way that the state of one immediately affects the other. Feynman would tweak the timing of his measurement by just milliseconds. The second electron's behavior shifts, reflecting the subtle influence of the first measurement. This isn't magic. It's quantum mechanics in action. It shows that even events separated in time and space are connected in ways that challenge our linear view of cause and effect. At the same time, relativity reminds us that time itself is flexible. If Feynman were traveling close to the speed of light, his clock would tick differently than a stationary observer's. Near a massive object, time would slow further. Two observers could perceive the same sequence of events in very different ways. This combination of quantum mechanics and relativity makes it clear that time is not a rigid, universal flow. It's dynamic, relational, and deeply intertwined with the fabric of the universe. Feynman's genius lay in making these ideas accessible. His diagrams and path integrals provided a way to calculate probabilities for every possible path, letting us model situations that at first seem paradoxical. Through these tools, we see that what appears impossible, events influencing each other across time, particles behaving as if anticipating measurements, is entirely consistent with physical laws. The so-called paradox is really just a reflection of how limited our intuition is when faced with the quantum world. Even in our everyday lives, these principles resonate. We often reflect on past decisions, wondering what if. While we can't literally step back and change the past, understanding that events are interconnected can shift our perspective. Every choice we make, no matter how small, interacts with other decisions and circumstances in ways we may never notice. Life, like the quantum world, is a web of probabilities and possibilities, each thread influencing countless others. Feynman's thought experiments also highlight the role of observation. In quantum mechanics, the act of measuring or observing a system influences its outcome. Reality isn't fully determined until it's observed. While this doesn't allow us to rewrite history, it underscores the active role we play in shaping the universe around us, simply by interacting with it. Observation, curiosity, and engagement all have consequences, subtle though they may be. Imagine Feynman looking at his chalkboard late at night, diagrams sprawled across it. He's thinking about electrons, photons, paths, probabilities. Each calculation reveals another layer of interconnected possibilities. He sees the universe not as a rigid timeline, but as a vast network of potential outcomes, each influencing the other in subtle, elegant ways. The past, present, and future are threads woven together, and understanding their interplay allows us to appreciate the profound complexity of reality. This perspective transforms the way we think about our own lives. Mistakes, missed opportunities, and choices we didn't take are part of a larger tapestry. While we cannot undo past actions, we can understand that they ripple outward, connecting with other events in ways we may only perceive later. Just as Feynman's diagrams reveal hidden patterns among particles, reflecting on our own actions can reveal the hidden structure of our lives, a network of cause and effect that is subtle, intricate, and meaningful. Feynman often emphasized curiosity above all else. By imagining extreme, even impossible scenarios, we stretch our understanding and sharpen our intuition. Exploring time paradoxes, entanglement, or multiple paths isn't about science fiction. It's about seeing the invisible rules that govern reality. It's about recognizing that even in a universe governed by strict laws, there is room for wonder, subtlety, and discovery. Finally, the study of time paradoxes reminds us that life itself is a kind of quantum experiment. Every choice, every observation, every action contributes to a complex, interconnected web of events. Feynman's work teaches us that the universe operates on rules that are subtle, elegant, and often surprising. By exploring them, we gain not only scientific understanding, but a deeper appreciation for the complexity and beauty of our own existence. If you followed this journey into the mind-bending world of time paradoxes, you've glimpsed the universe through Feynman's eyes. Curious, playful, and deeply analytical. You've seen how quantum mechanics, relativity, and careful observation reveal a reality far stranger and more interconnected than our intuition allows. And if you want to continue exploring ideas like these, there's so much more waiting for you. On my channel, Physics That Hurt, we dive into concepts that challenge what we think we know, connecting science to life in ways that are both mind-expanding and relatable. So don't forget to like this video, share your thoughts in the comments, and subscribe, because curiosity is the first step to seeing the universe in all its astonishing detail. Time may not let us step back and rewrite history, but curiosity, observation, and wonder allow us to understand it, and in that understanding, we find both knowledge and meaning.